My name is Sara Chips. Like he said, I'm from New York. I'm building a hardware company called Jewelbots. A little bit about me. You've heard what he said. So I've been building software for 15 years as a developer and as a CTO, and I've really loved the software community a lot. So when I started hacking on hardware, it's been about 4 years. A lot of Arduino stuff, and I was like, well, maybe I can build a product. Maybe we can build a product. That sounds really fun. So Jewelbots was born of that and a passion to get more girls interested in STEM, because I started hacking when I was 12. I wasn't 12 in 2001. I won't tell you when that was. Instead of me telling you about it, we have a video for you to watch narrated by my amazing co-founder who has a great voiceover voice. So if you can hit the video.
Jewelbots are smart, programmable friendship bracelets aimed at girls. But they are more than just pretty jewelry. They're wearable technology designed to excite, connect, and engage the girls that use them. Each bracelet has interchangeable charms and bands that the girls can buy separately and mix and match. Jewelbots connect to each other over Bluetooth, and girls can set them up to match their friends when they are nearby or send secret messages in their own languages. This unique, proprietary technology is made possible by our patent-pending electronics. And of course, Jewelbots are completely safe. There's no GPS tracking, and we do not store any kind of personal information on our servers. Alone, girls can interact with their environment through notifications and alarms by pairing the device with a Jewelbots smartphone app. For example, the girls can program different patterns to light up when they get a new follower on social media, or when the weather app says it's going to rain. But Jewelbots are so much better with friends. The more friends they have nearby, the brighter their Jewelbots glow. When all the girls in the same group are together, their Jewelbots go into rainbow party animations. The truly exciting part is that Jewelbots are completely open source, so girls are empowered to create their own custom features. They just plug their Jewelbots into their laptop, and they can upload their own Arduino-compatible code. Over time, girls can unlock special light patterns and features by wearing their device and engaging their friends. If they don't want to wait to supercharge their Jewelbots, they can upload the code themselves. Either way, Jewelbots are a fun, collaborative wearable that girls can enjoy for years to come.
Great. So now you know what we're building, and you've seen a little bit of it. I'm wearing one right now, these little guys. So today's talk, I'm going to go over quite a few things. But the main point I want to make, well, first of all, who's here? How many of you are working, have a software background? Do you mind raising hands? Great. How many here have done hardware? Okay, great. That's a great mix. Okay. So the biggest thing I've learned while building a hardware company is that software is pretend. It lives in a computer. It's not corporeal. You don't have to actually build anything that you can hold in your hand. And that was a big surprise to me. I assumed that hardware was the step up from software. Like, I built software for so long, now I can do hardware. Like, this is the next step. And hardware is really complex compared to software. One thing, I'm going to complain about a lot of things in this talk that I've learned on the way, but I have to say that building this company has been an incredible experience. And while there's been a lot of surprises, there's nothing like holding something in your hand that you have worked for more than a year to design and build and having people excited about it. So it's been a great experience in general. Here are just some surprises that I encountered along the way. So we're going to go over several things today: prototyping, debugging, user testing, proving traction, I have it here too, design for manufacturing, and manufacturing in general. These are all covered in a Medium series I did called So You Want to Build a Hardware Company, except for manufacturing. That's something that's new. That'll be coming out sometime over the next couple of weeks. So when people come up to me and say, I want to build a hardware company, what should I do first? I tell them the first step is build the shittiest version you've ever seen of what you want to make. This is effective in first testing your technology, making sure it's something that will even work. A lot of things sound great in your head, and then you actually build it, and you're like, this is stupid. No one would actually use this. that happened to us early on when we we thought a good thing to build would be a bracelet that changed color based on your outfit. So girls can wake up in the morning and be like, oh, great, like I'm wearing blue today, I'll make my bracelet blue. And so we built a really terrible version of that and went to high schools and was like, what do you think of that? And they were like, that's the stupidest thing I've never heard. I'd never use that. And we're like, oh, okay, we thought that was a good idea. But it was we didn't go through like a 3-year process of building this thing and then learn. Another thing it does is also, if you come from software and you have someone from business, like just graduated business school or has a business background, come up to you and they're like, oh, will you be my technical co-founder? And you're like, I'll give you 10% of the company and all you have to do is build everything. And you're just like, absolutely not, I'm not going to do that. You would like to see them build first a terrible version of what they're thinking of to show that they care. And that's another way to getting people on your team is, your version's going to look awful. So those were little bits. You can use little bits for prototyping. Here, I'll go back. These are little bits. They're little modules that you can kind of stick together and make home automation stuff. There's a Bluetooth module. There's a cloud module. There's all kinds of stuff, servos. You could use this, or Arduino is a great way to prototype. I actually think that's why there are so many hardware companies coming out, is because so many people found Arduino and was like, this is great, I can do this, and wow, I wonder if a lot of people would use this. Another good way to start prototyping is by taking things apart. You can Google pretty much anything and deconstruction, any product and tool, and you'll see someone taking it apart and figured out what is making this device, like a Fitbit or anything similar to what you want to build. You'll learn what you need to put in your product. This was, so prototypes go in generally 2 parts. A works-like prototype, like this is a prototype of what my device will end up working like. This is a functional prototype, and a looks-like prototype. Looks like this is what I would like it to appear like. Usually that's because you can't usually fit the works-like part in the looks-like part, because Arduino and things like that are larger usually than you want something to build. This was our works-like prototype super early on. It was a bracelet that changed color based on your sentiment analysis of your tweets. So if you were having angry tweets, it would be red. That was an early prototype that we built. This was our first looks-like prototype. There's nothing actually in there. That is just the bracelet that we thought, this looks beautiful. This is kind of the style we're going for. So we could show people both and be like, this is kind of what we're trying to do. Debugging in hardware is very different. Debugging in software is infuriating. It's a semicolon. It's, I used the wrong library. I've never done this before. It won't compile. In hardware, because you're usually soldering things together or using components that you got in the mail or working with something you've never worked with before, things can go wrong. And because it's physical, you need to try a whole bunch of different things. So these are some great tools for when you're debugging. Some tips before you get started is always order 3 of everything, if not more. Because what happens is there's a 2-week lead on it, right? You're ordering parts, you want a prototype, so there's a 2-week lead. If you order 1, there's a good chance you'll break it or short it out, or even the one they sent to you is already broken. So in order to do that, I usually order a whole bunch of whatever I'm going to try, and worst case scenario, I have a whole bunch of extra units. I found that using leaded solder is better, even though it's not as intuitive. The unleaded solder is breaks apart really quickly. Masking tape is a great tool, or duct tape, or any of those things. Soldering is hard. I hadn't soldered before I started hacking on hardware. I didn't do it in school. And so you used to get burn marks everywhere and that kind of thing. I rarely solder now. Radio Shack. Do you guys have a Radio Shack out here? I don't know if that's a chain out here. It's a rare chain, at least on the East Coast in the US. It's really hard to find parts. And Radio Shack is going out of business, but they have a lot of stuff. I'm pretty sure I was their only customer last year, so that's why they're going out of business. So multimeters. Multimeters you can buy online. They're usually about 20. You can get them anywhere from $20 to like hundreds. Basically, they are great at measuring current and telling you what, and resistance. What I use it for all the time is current flowing from this point to this point? Like I have a microprocessor, is the current even coming from the microprocessor to my servo, that kind of thing. But you can do all kinds of measurements with a multimeter. Desoldering. So it turns out that you can solder things and you can also desolder them. And that can be a great tool. There are things that you can use so you don't make a big mess and you can still use a product again. So there's this copper wire that you can use that helps to pull the solder out from whatever you're using. There's also these tiny little vacuums that you can use. I haven't found them to be too helpful. But you can always change what you've done before. Oscilloscopes. Oscilloscopes are good to measure modularity of current. So you can debug things like LEDs or things that aren't supposed to be getting a steady stream of current. These are expensive. Usually a school will have them or like a local hardware company. It can't hurt to send an email so you can say, hey, do you have an oscilloscope? Because I really could use one. They can go anywhere from like $300 to thousands and thousands of dollars. Next up, we have user testing. So I have not been 10 years old for a long time. Neither of any of us. At least I don't think. I don't see any 10-year-olds in the audience. If I were to build this device for me, it would be very different. It would probably be gold and have lots of cool gemstones on it, or any of the things that I wear are very different than your average 10-year-old girl wears. So as a result, I've spent a lot of time with 10-year-olds over the past couple years. We have found them through schools. So schools get very excited if you reach out to a teacher and say, hey, I'll teach a free electronics class in exchange for talking to some of your kids about what I'm building. I don't know what the budgets in schools are like here, but in the US, public schools don't have the budget to get curriculum together, nor do they have the budget to pay people that know how to teach computer science. So having someone volunteer to come is exciting for them. No matter what demographic you're working with, you can host a dinner, be like, hey, trying to build something for people like you. If you don't mind coming by and giving me some opinions, that would be really helpful. So our first step was drawing a whole bunch of sketches. We drew, this is one sheet, but we had about 50 different designs that we ended up sharing with the classes we were working with and asking them to vote. The last thing I wanted to build was a bracelet with a flower on it to say, like, hey, this is how your daughters will learn to code. Unfortunately, every class we sent this to picked the flower. So, who am I to say you can't have your flower? So our first device is a flower. It comes with a flower charm and a robot charm. So you can use either. Based on that, we iterated on some designs of flowers, sent it to them, got their opinion. This is a slow process. Designers like to sit with your end users. That's always super helpful. So this can be while you're building your electronics and you're designing, you can do those things in parallel because they're both a long process. So start them both at the same time. Now, this is where we are. We sent this to our backers last week. We're actually, a little more, so we've sold almost 5,000 Jewelbots so far in pre-sales. We're shipping our first 50 in 3 weeks, and the rest of them over the next 2 months. Showing traction. Hardware companies are not cheap to build. You need money. I don't know anyone that has bootstrapped a hardware company. I know people that have bootstrapped and done a crowdfunding campaign, but unless you're independently wealthy and can, pay 5 engineers for a couple years, you're not building a hardware company is difficult. It'll be very slow. So we took to raising money. We met with several venture capitalists, and the first thing we heard was, show me your traction, which is difficult. We don't have a product yet. We haven't shipped anything yet. We have girls telling us that they want this. Is that good enough? No. They want to see, show me that this is something that once you build it, people will even want. The first thing we did that was valuable to them was file a patent that covers our technology. So Jewelbots use a mesh network to communicate from device to device, so you don't need a phone. One thing we learned early on is that these girls are not allowed to have their smartphones in school, so we can't use them like most wearable devices do to piggyback off of to get signal. So Jewelbots has a patent that covers wearable devices using mesh networks for communication, and that is something that investors find valuable. And then the second thing we did was a Kickstarter campaign. Kickstarter is not cheap, and it's not, which is kind of counterintuitive, right? But in the beginning of Kickstarter, you could film a video at home and put it online, and people would be like, that's very cool. But now you have companies spending $20,000 on a video with really high production value that you're competing with. Our Kickstarter probably cost about $15,000 to put together, and it took about 3 months to build. However, leading up to it, we did a lot of outreach to press, a lot of people talking talking to us, and we had a task for every day we did our Kickstarter that allowed us to do a lot of outreach, and as a result, we multiplied our goal by at least 5. Even, you don't have to play this, even Bill Nye sent us a video. It was the craziest thing. Halfway through our Kickstarter, we get an email from Bill Nye. What? He was doing a Kickstarter too, and he was like, he put a video together being like, Jewelbots are awesome, you should totally back them, and just emailed it to us. It was the craziest day. I screamed really loud in the middle of the office. But that was very cool. And so stuff like that, we still show people the Bill Nye video when we were fundraising earlier this year, and that's definitely impressive. Design for manufacturing. So we built a whole bunch of messy units, did a bunch of user testing, finally figured out what we wanted to do. But manufacturers can only build in a certain way. It's not like they can make any type of product. They can, but it'll cost you a lot of money. One thing about us is we were trying to keep our cost of production fairly low, so we don't have to charge too much for Jewelbot, because we know that these girls don't spend $300 on jewelry. So we iterated a lot on the product design. You can talk to people in manufacturing. You can find people that have done this before and talk to them. We have people on our team that have done it before. So people can tell you, look at your designs and say, okay, here's what you can do and here's what you can't. Here's what's going to be expensive and here's what's not. Another thing you have to put together is a bill of materials. And that's basically a list of everything that goes in your product. That turns to be a lot. We have like 40 things on our list. And they come from like resistors to microprocessors to all those things. And so when you start design for manufacturing, you also want to look into sourcing, meaning, can anyone sell me this part in thousands to 100,000s of units? How long will it take them to ship it to me? Often, something that happened to us early, and something that happens often, is that you'll be using a product and or you'll be using a module and it's fine, and all of a sudden another company will go into production with it and buy it everywhere. So things that only took you a week before are all of a sudden sold out for 4 months. And you're like, oh shit, like how do I fix this? So learning that in the beginning of design for manufacturing is better than learning it when you're about to go into manufacturing and now you know you have to push back X number of months. This is 3 iterations that we went through while we were designing next to an Apple Watch. So the Apple Watch is the one all the way on the right. 3D printing. Every design we did, we got a tiny little, we have a Lulzbot, which is a 3D printer, very highly rated and inexpensive in our office. So every time we come up with a new design, you want to print it out. There are also services. I saw that the CEO, I think, of 3D Hubs speaking here. 3D Hubs is a great one. We used it a ton. And you can send your 3D designs to one of these services, and they will mail you a product. And they can do all kinds of different resolutions, so you can see exactly how it works and test with your end users. This is a rendering of what we ended up with. It includes all the mechanical parts, the battery, motor, that kind of thing. Firmware. I threw this in here, but this is something really important to know before you get started. Firmware is the absolute worst. You would think that, well, I've talked to a lot of people, and they agree. You would think the hardest part would be making the device. Imagine the world of software if there was no open source, and every company thought what they were doing was proprietary and wouldn't share it with you. That's the world of firmware. There'll be sample applications that a microprocessor company will come out with. They don't show you the code. It's just a test that the microprocessor is working. They will not tell you how to write the code. They give you a data sheet. And you have to put the code together based on what you learn in the data sheet. Unfortunately, often the data sheets are just wrong. So you'll build something. You'll find out that it's not working. So you debug for 2 weeks. Still not working. You're like, OK, reach out to the manufacturer. What they want from you is a sample application that uses it so they can redo what you've done and show the results. They can replicate what you've done. Often, they're like, oh, sorry, the docs are wrong. We already knew about that. And it's like, if you knew the docs were wrong, why don't you change it? And that's what open source has done for us, right? Because that's a pull request, right? Someone figures out the docs are wrong. They do a pull request. The docs are right now. There is no pull request. This is going to happen to a dozen more people, and they really don't care. So that's firmware, and it tends to be very difficult. Manufacturing. I have 3 minutes left. OK. Manufacturing, choosing a manufacturer. So you want to talk to as many people as possible. We compared 14 different manufacturers here in the US and in different countries. There are companies that can do this that you can hire, and they'll contact all their manufacturers. And the things that they do are the sourcing. How much will it cost for my microprocessor from this manufacturer to this manufacturer? Another thing it allows you to do is say, hey, these guys will sell it to me for $1. Why are you charging me $10? Let's talk about that. So even if you've met someone that you really like, you want to get a couple different quotes so that you can compare them and know what different people will cost you. Package design was the thing that blew my mind the most when I went to Shenzhen, because I was like, wow, someone designs packages. That's their job. That may not be surprising to you, but I open packages. I rip them apart, and I throw them out. Even the wonderful Apple packaging that's just beautiful, I just take for granted the fact that Apple just does this. I didn't know how I thought it happened, but I just never thought about it. And package design is a big part of your process. It needs to start before you're looking to manufacturing as part of the DFM process in order to design something that is inexpensive, and your manufacturer is going to want to see your package design so they can estimate how much each package will cost you, because it's part of your BOM. You also want to talk to people about tooling. So tooling, right now, we're having a big steel tool made. It's about 3 feet wide and 2 feet tall. And it's like a monster heavy thing. We're going to put it in our office and use it as furniture afterwards because it's costing us $20,000, so we've got to do something with it. But when you're making something, especially working with plastics or anything you work with, you're going to have some custom tools built. So tooling is a very expensive part of the process that you should account for budget-wise. For example, this is our charm. We want it in 2 colors, which means this is the most thing that stressed out our mechanical engineer the most when I told him I wanted 2 colors, because that means that it needs to have a double shot of we're using like a polymer blend of a lot of materials. So it needs 2 shots, and that means 2 molds, and that makes things more complicated. If I wanted 4 colors, we might be spending $40,000 on tooling, because things get pretty crazy. So you want to confirm, and then you can change your design to make it easier. If they're like, You need to spend $200,000 in tooling. You can be like, OK, what can I do to make that smaller? So that's it.